What's up, everybody? This is Sean Spartman coming at you pre-recorded from the brand new Cutting Edge. And today we're going to work on a division problem using fractions. So, our problem is Larry the frog can jump 1/3 of a foot for every hop he takes. How many hops would it take Larry to travel 4 feet? So first we want to figure out what it's asking us and set it up in an equation. So it's asking us how many jumps will fit in the distance 4 feet, basically. And so it's asking us how many jumps of 1/3 of a foot distance fit in 4 feet of total distance. So our division problem would look like this here, 4 divided by 1/3. So that's what we're looking at. I'm going to go ahead and write that down on the bottom to keep it in the periphery while we work through this problem so we remember what we're trying to solve. So we can represent this in a couple different ways, but we're going to start with a more linear model since it fits the problem well. So if I have here my 1 unit, this is going to equal in our problem 1 whole foot. Well, we know from fractions and the definition of parts of a whole that 1/3 of a foot would mean that it would take 3 of these partitions or equal parts to equal our 1 whole. And so we know that for every 1 whole foot, 3 of these jumps or these hops of a distance of 1/3 would add up to equal 1 foot. So first we need to make our complete distance using our unit. So that's what we're going to do now. We're going to start at the very end of the board and mark our distance here and get it right about there. And we need 4 of these. So we need 4 whole feet. And so we're going to do this 4 times. It just so happens that this board is 2 units long, or in this problem, 2 feet long. So I'm going to keep creating my distance here. And we'll just, for speed's sake, transfer down here for our final 2 feet. And you can see here that they are still equal. That's still 1 unit, or 1 foot of length in our problem. And so now we need to label our distances. At this spot, you would be at 0 feet. At this spot, you would be at 1 foot of distance. At this spot, 2 feet. For space purposes on here, so I don't have to use 4 feet of whiteboard, we just continue our 2 foot measurement here. This would be 3 feet of distance, and finally 4 feet of distance. Okay, so we know from previous lessons that when we're dividing, we're really just subtracting multiple times. So what we're going to do in this problem is we're going to keep subtracting these 1/3 of a foot distances until we make our way back to 0 feet. And then from there we will know how many thirds fit in 4 whole feet of distance, which is what that problem was asking in the first place. So now I'm going to mark off my distances. So we'll start at this 4 foot mark since we're going to count backwards. Since that is what subtraction is, it's counting backwards. We're going to mark our distances. So we have 1 there, 1 right about there, and then as you would expect, after our 3rd partition, we have made it 1 whole foot, which is what you would expect from the parts of a whole definition. We continue on. We have a spot here. We have a spot here, and then as you would expect, 2 feet is where we end up there. Continuing at the top, we have a spot here, a spot here, and then a spot at the whole foot, as you'd expect after another 3rd partition. We have another spot here, and then another spot here, and then lastly, we're finally back to our 0 feet, or in this case, where our frog would have started. So now we need to know how many hops it would take. So now we simply count how many of those distances fit in 4 feet of space. And so we're going to count. We have 1 hop, 2 hops, 3 hops, 4 hops, 5 hops, 6 hops. We continue up top, 7 hops, 8 hops, 9 hops, 10, 11, and we have 12 hops. So that tells us that 12 hops, and these hops are 1/3 of a foot each. 12 hops fit in 4 feet, or 4 holes in this scenario. So our answer is 12 hops, because the question was asking us how many hops it would take to travel those 4 feet. So that's one way to solve it, and that's going to be a more linear approach to it. We can also solve this using our geometry figures. So in this example, we have to let a couple shapes represent our parts in our holes. So in this one, we're going to let this hexagon equal 1 hole. In this problem scenario, this is going to be 1 foot of distance. And if you see here, in this model, our rhombus, or more exactly, our rhombi, can fill up the entire area of this shape. In fact, it takes 3 rhombi to make the same area as our hexagon. And so, from the parts of a whole definition, we know that if we had just one of these 3 partitions, it would equal 1/3 of our whole. Since our whole is 1 foot, then 1/3 of that would simply be 1/3 of a foot. And this would be, of course, the hop distance. So we'll keep that there so we know that in this context, the rhombus is going to represent a single hop from our frog Larry. So now what we can do is we can take 4 holes. In the context of the problem, this would represent 4 feet of distance. And then we have a certain amount of hops, or rhombi, that we know are 1/3 of the whole, and we simply figure out how many rhombi it takes to take up the same space in our geometric model. So we'll do that. So I'm going to fill in these hexagons. Of course, as we've described already, you should expect 3 of these to fit to take up the whole hexagon, because one of these is equal to 1/3 of the whole. They're a little slippery here, so we're going to have to kind of wrangle them in. But as you can see, as we complete this model, we have a set number of hops that perfectly take up the same amount of space as our 4 holes. So now all we have to do is count how many rhombi, or in the context of the problem, hops, it takes to fill them up. So now we simply count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And just like from our last model, we get 12 hops to cover the entire distance of 4 feet. So we've shown 2 different models explaining how the answer to this problem is 12 hops. So if we go back to our original equation that we set up from the problem, 4 holes divided by 1/3 of a hole equals 12. Or in sentence form, 12 parts of 4, where each part is 1/3, will equal 4. So 12 thirds is the same as 4.